Greetings, math fans. All right, so this is day two, and what we're going to do in day two is, first of all, talk about something. It's called the alternate definition. Something right here, day two, and we're going to talk about the alternate definition of the derivative. Okay, and this is going to be at a point. All right, so let me first describe it. We've done this before for doing the derivative. Okay, but if I have a function here, and this is going to be p of a comma f of a, and this guy here is going to be q, which is x comma f of x. Okay, and the distance, let's put some markings here. Okay, this distance right here is going to be your delta y, and this distance here is going to be your delta x, or change in x and change in y, right? All right, and you guys know that our slope is change in y over change in x. Of course, it is our good friend the Yox. Sweet. All right, and so before what I did is I said the limit as h approaches 0 because I was closing in the gap. Remember, we wanted that secant line to be the difference between smaller, smaller, and smaller, and that's why we said h approaches 0. And that then the secant line becomes our tangent line, right? A good approximation of our tangent line. Now what we're doing is I am telling you my delta x is approaching, or my x is approaching a. So this value right here is approaching this value right here. All right, so this is what it is. Well, first of all, let's keep going with our slope. Don't you agree with the slope is, if I actually use my x, f of x, a, and f of a, it's f of x minus f of a all over x minus a. All right, so I'm going to say this is my alternate definition. F of a is equal to the limit as x approaches a. Okay, because again, these two values I just marked here, this guy here and this guy here, they're getting closer and closer and closer together. Okay, those 2 points. So limit as x approaches a of f of x minus f of a all over x minus a. That is the alternate form of the definition of a derivative. Okay? Couple things here, math fans. Okay, first of all, how do you know when to use this? Okay, well, a couple ways to know. One is if I'm trying to find the derivative at a point. But the way that you're going to know for like your homework and for a quiz, if I ask you to use the definition, the alternate definition, okay, I will be very specific about that. So we're going to say find the slope of the tangent at x equals 4 of y equals 3x squared. All right, so we're going to say y prime, or better dy dx, right, the derivative of y with respect to x, that's definitely better, is equal to the limit as x approaches a, and our value a is going to be 4 of 3x squared. Okay, that is our f of x minus f of a, and a is just having the point in there, so minus 3 times a squared all over x, right, minus a, or x minus 4. All right, so just remember that. That is our value of a, and our f of a is, just to kind of write everything out here, f of a is 3 times 4 squared, because that's what our y equals 3x squared is our function, right? Okay, so it's pretty easy so far here, right? Limit, let's simplify things, as x approaches 4 of 3x squared minus 48 over x minus 4 equal to limit. Notice I'm writing limit each time, which you need to do. I'm going to factor 3. I get x squared minus 16 over x minus 4. Oh, look at that. Sweet. Limit as x approaches 4. I can factor that. X plus 4, x minus 4 over x minus 4. X minus 4's cancel. And then I can do direct substitution, which is going to give me 3 times 4 plus 4, which is 3 times 8, which is 24. Okay? That's what it is, math fans. That's just a different definition using, again, as x approaches a value as opposed to h approaches 0, as opposed to the gap getting closer and closer. Not used as much. Truly, we use h approaches 0 more so. Okay. So let's go to graphing f prime given the f graph. Okay, math fans, this is so important. I'm going to put a little star here, or an asterisk. Okay, I want you to remember that f prime is the slope of f at a given point. Okay, that is so important here, so important. F prime is the slope of f at the given point. Okay, so real quickly here, if my x-axis for this is my f prime graph. The x-axis are x units. So those units actually stay the same. So if I go over 1, my x unit is 1 for f graph, then it's also 1 for f prime graph. That's actually pretty easy. That's like comparing apples to apples. This is one where it's a little more challenging is the y-axis are slope units. Okay, what you're going to do is you're going to estimate. Sometimes you're going to estimate. Okay, so estimate the slope at various points. Okay. Couple things that are easy. First of all, it's easy to get slope equal to 0. Okay, and think about it. Where is a slope equal to 0 on a graph? Let's just make a quick sketch here. If I just give you like a graph like that, okay, where is the slope equal to 0? Well, isn't the slope equal to 0 right here? And is the slope equal to 0 right here? So where is the slope equal to 0? It's equal to 0 at max and min points. That's important. Okay, so that's the first thing. Slope is equal to 0 at the maximum and minimum points. Now what about where's the slope? Where's the slope a max or a min? Okay, well let's look at one point here. I'm going to do it in red. Do you guys agree that right here, isn't the slope probably the maximum value right here, and then it starts to go less steep? Okay, so I use the word steep. So this is the deal. The slope is at a maximum or minimum at the steepest where it's the steepest slope. Okay, so if I would continue, let's just continue this graph here, right? Isn't the steepest point somewhere over here? It's certainly not as you get closer and closer to this maximum or this minimum point, right? Here's the slope. It gets less steep, right? Until you get to 0, which is what the first one we talked about. And then it gets steeper and steeper and steeper, and then all of a sudden you're at the steepest point, and then what happens? It starts to get less steep until you get to 0. Okay, and then it gets to get more steep, and again, it might be over here at the steepest point. So you need to remember that. Those are kind of two easy points to be able to plot. All right? Well, let's do a couple examples here now. given this is your F graph. Okay, so I'm going to be pretty specific on a couple of these points here, so give me a second to write this down. All right, so here's your F graph. And I want to create an F prime graph. All right, so again, F prime represents the slope. It's a slope graph, slope of the tangent line. All right, so if this is my original function, these are actually pretty easy because don't you guys agree? What is the slope of this line? Well, the slope is, isn't it up? Well, we can go to either point, but that's up 1 over 2, up 1 over 2, right? So isn't the slope here 1/2? So what I can do is from x equals -3 to x equals 1, the slope is 1/2. So from -3, remember x coordinates are, it doesn't matter, it's the same for x, right? X axis is x units. So that means from -3 to +1, my slope is 1/2. Okay, and there it is, 1/2. Okay, and notice it's just it's a horizontal line because the slope is constant between -3 and 1. And notice another thing too, these are open dots. Okay, they're open dots, which, first of all, talking about endpoints, I don't know what's going on the other side of the endpoint. So it is an open dot. Do not know what's going on. Okay, very, very important. If I did, it could be a closed dot. You don't know, but I don't know what's going on an endpoint, so it's going to be an open dot. And the other point that's open on the right-hand side by 1, do you guys agree that what's going on the other side? Well, the slope is changing. So at this point right here, math fans, the slope is changing. So I can't say it's 1/2 there because I really don't know what the slope is at that point. So that's why it's an open dot. All right. Okay, so let's keep going here. Now, do you guys agree that my slope from 1 to 3, it's going down 2 and over 2? Okay, so my slope is -2 over 2 or -1. Okay, so that means at -1, I put a dot there from 1 to 2, and I draw my line. And that, again, here we have an open dot on the right-hand side because it's an endpoint, and I have an open dot on the left-hand side because, again, the slope is changing at the value of x equals 1. Okay, so that is the F prime graph, or the slope of the tangent line of my original graph of my F graph. Okay, it's not too bad. Let's do another graph that's, and again, remember how I mentioned here that you have to estimate the slope at various points? You're not estimating the slope here. When it's constant, you know what the slope is. All right. This next graph is going to be more of an estimate. So let's do that one. Okay. So this graph kind of just appeared quickly because I didn't want to waste time having you guys watch me draw the graph. But this is your F graph. Now this is a little bit different, math fans, because you're kind of estimating slopes here. Okay. Well, we're estimating some of the slopes. Like, for example, I can do a couple different things here. I know a few things that's going on. If I look at this value right here, I don't know what my y value is starting at. Is my y value starting at 3, at -3? I mean, I don't know what it's starting at. The only thing I know here is that my slope at that point is it's positive, right? It's a positive slope. Okay, so it's probably let's look at a couple points that I do know. First of all, do you guys agree? I'm going to highlight a few things. I pretty much know this slope, and I know this slope at that point. Do you guys agree with that? I know my slope is 0. So let's go to our x at -1. The slope is going to be 0. And the slope at 1, 2, 3, 1, 2, 3 here is going to be 0. I definitely can plot those points. And I also know this guy right here. Kind of know that one. Okay, it looks to me that that is the steepest slope there. And is that slope a positive slope or negative slope? Well, just look at the graph. Isn't it a negative slope? It's going down, right? So if it's a negative slope and it's the steepest at 1, I'm going to put, this is probably my lowest value here. It's negative value. Now this is really important, and I'm going to write this out in red here. If you are above this line, it's a positive slope. If you are below this line, it's a negative slope. Okay, it's so important you guys recognize that. Okay, so very important. All right, do you guys agree if I'm looking at this point? Well, of course, I said that this is the steepest part right here. Okay, and that's 0. But do you guys agree at this point right here, that value? Okay, I'll erase that now. But that value right there, it is a positive slope. And it gets, as I'm getting closer to -3, it's steeper. So this is kind of what that graph is going to look like, math fans. Okay, it's going to look something like this. Okay, and that's a pretty rough sketch. Again, it's an estimate, but point a couple things out here. This value right here, it's a positive slope. Do you guys agree? Because this is a positive slope here. And then when it hits this point right here, it starts to go negative. Okay, but again, this point right here, that was my 0 slope, and now it's negative. Because remember, below that x-axis is a negative slope. So and this is the steepest point right here, and that's this point right here. That's the steepest, and then it's still a negative slope here. Do you guys agree with that? But it's now getting less steep because it's approaching this point right here, which is 0. So it's still a negative slope right here, but not as steep. So now it hits this point here, which means it's a 0 slope. And then what happens? The slope becomes positive, and this is what I'm talking about. That's the slope becoming positive. So you've got, when you're doing these problems, you've got to ask yourselves every time, what is the slope of that line? Okay, because it's really, really complicated sometimes to think about that, but you got to ask yourself, what is the slope of the line? All right. So, a couple things here I want to talk about yet. I want to go to my website real quickly, and I have this actually on here. Okay, if you go to my website, which of course you obviously went to the website in order to get this lesson, there's something called Derivative Grapher. I think it's a great website just to help you practice the derivatives. So if you click on it, okay, it takes you to this nice friendly site here, and it allows you to type in your own examples. There's demo examples, or you can use user-defined examples. Let's look at some of the demo examples. This is an F graph. And basically, if you grab this little bar down here and you drag it across like this, it shows you the approximate slope of the tangent line at that point. Okay, that's a great one. So it's great for actually looking at it and then kind of figuring out and saying, at this first part here, on the left of the y-axis, it looks like a negative slope. And it looks like it's a pretty steep negative slope, and then it becomes less and less. So if I drag it, it's a negative slope. Look at where my line's coming from. Ah, it's coming from the negative part there, right? That's a slope, and it's pretty steep. And look at that, okay? And then it goes to, again, another negative slope. So look at that. It's going negative, and then what happens? It switches to a positive slope, right? At that point, right? This is this value right here, okay? That is a slope of 0, and sure enough, look at that. When I hit that point, its slope is 0 because this is 0 right here, right? And then it becomes a positive slope. Goes up. Okay? And there's a lot of different graphs. You can hit next example. Okay? What's the derivative of that? Well, isn't that a constant? Isn't that slope some positive value? Well, let's check it out. Look at that, man. It is a constant slope. There it is. Okay, here's another example. Okay, well, isn't the slope negative for the left-hand side of that absolute value, and then positive for the other half? Well, let's check it out. There it is. It's negative. It's constant, though. Then as soon as I hit 0, what happens? Oh, it becomes positive. It's a jump over there, isn't it? Okay, so, again, here's another one. It's a positive slope until you hit that peak, which is 0. So it's a positive slope, and it gets steeper right there. And then as soon as it hits that peak, watch, it's hitting the peak. It's getting close. Oh, it's 0, and now it becomes a negative slope. And notice here, this is a good example here. Notice that this value right here, it's a steep slope, right? Okay, that's why that goes steep there. And then when it hits the peak over there, then that's a slope of 0. Okay. Anyway, it's a great little tool to just kind of practice your graphing derivatives. All right. You can even put your own user defined ones in there. The only thing you have to be careful about is when you use multiplication, just put 2 times. They even give you some examples here, math fans. Here are the examples right there. Okay. You guys see it over there, right underneath the red here. Enter a function of x using common syntax. Okay, so you can enter your own graphs in there, but it's a great tool to practice derivatives. All right, math fans. One other thing I wanted to show you. I brought this graph back up again here. Okay, and this is my F graph. If I want to actually estimate the slope at, let's just say, at x equals 1. Okay, so at this point right here, I want to say, well, what is the slope? What you're going to do is, you guys remember the average rate of change, what we did before? You look at points on either side, and you kind of get an estimate value here of what's going on. That's exactly what I'm going to do. If I want to estimate my slope, I'm just going to do basically pick a point, and I'm going to I'll pick this one and this one, because those are kind of easy ones. Those are ones that I've identified already. And I'll say f of -1. So it's really my y value, isn't it? y2 minus y1 over x2 minus x1, right, to find your slope. So that's what I'm going to do. F of -1 minus f of 3, the y values, over -1 minus 3. Okay, and then if I get my values, of course, f of -1 is 2, and f of 3 is -2. So it's 2 minus a -2 over -1 minus 3. So we get 4 over -4. So my estimate of that is -1. All right, and it's again, if you kind of look at it, it's kind of a good estimate, right? It's down 1 over 1. It looks like a pretty good estimate. But that's how you estimate if you're given some data. It's a good way to look at either side, use your average rate of change, and kind of estimate your slope. So that's it, math fans. Again, the thing I have to stress the most is when you're doing a slope graph. Let me just delete this one more time here. I've got to stress that. It's so huge. When you have a slope graph, anything above is a positive slope, and anything below is a negative slope. Okay, it's really easy to confuse that. But if you're not sure, just look at the slope of the original graph and say, oh, is it going up or is it going down? If it's going up, then the slope graph better be above the x-axis. If the original graph is going down, if it's a negative slope, better be below the x-axis for the slope graph. All right? Anyway, that's it, math fans. Have an outstanding day. Goodbye.